What is going on, ladies and gentlemen? It is Jake, aka StarCoding, coming at you with yet another video where we're talking about, you guessed it, computer science. It has been a minute since I've uploaded a video. Life, what can I say, guys? It's full of surprises, it's beautiful. Nothing bad's been happening, but you know, life happens. So, I've been out of YouTube for a bit, and I want to get back into it. And I thought we would ease our way into making a video about strings and malware analysis. So, let's jump into it. Now, I said this was about strings and malware analysis, but that's because that's something on the side I'm kind of looking into right now. I hope to have some more videos about it in the future, but really what this is a video about is how to not get pwned, guys. If we're making desktop applications, if we're making stuff for people that is going to be downloaded on their machines, if they have control of the code, we do not want to hard code anything into that application unless we absolutely have to. And this is hopefully is going to show why. I think everyone knows that, but why is it a bad thing? Hopefully we can get a little bit more a live action look at why it's bad. Cool? Sounds awesome. So here we go. We're in the directory. Let's check out. We have a file called loginform.exe. Okay, what is this? We can use a file command to check out what it is. And we can see that it is a PE32 executable, which just means it's 32-bit executable file for MS Windows. Very cool. And if we wanted to, we could use this exif tool on the login form as well, just to see some, you know, extra stuff about the file, kind of its size, which is kind of cool, as well as the meme type. Yeah, some linker version, very cool, very cool. There's an entry point as well into the code. So, what are we going to do? Well, there is this very cool tool called Strings on Linux. It's also on Windows as well. You can download it as a 32-bit executable and file and use it on Windows as well. But on Linux, we can use it in the command line as we're seeing here. So strings is going to print the sequence of printable characters in files. So it's just going to print all the ASCII text that makes sense into the terminal, which is cool. So let's get out of that. And maybe let me make this window a little bit smaller, if that is possible. Hello. Okay, so we got our window resized. Let's hop our boy into the strings and see what is outputted. And we can scroll up and see there's a lot of information that's outputted to the screen here. I mean, it looks like we have some function calls, kernel32.dll, some dynamically linked library. Okay, very cool stuff. We keep scrolling up. You know, some more random information, some I data, some RTC data. Very cool. And we finally get to what looks like human sentences, which is very cool. What are we looking at exactly? Well, let me just open up a window here. And so usually when you're like actually outputting the file context of some sort of binary, like this was a PE file, so this is how the data is going to be organized and look like when it's outputted. That's not the preface of this video, but if you were curious, you could look into some PE formats. If you were to compile a Go or a Java file, it's going to be slightly different, possibly, and so you would want to, you know, check how that binary looks, what you should be expecting to see in strings when you type in that strings command. So we have some strings, which is very cool. Let me open up the virtual machine again. So we have some strings, and you know, in a terminal, it's kind of clunky to move around in. So what Jake likes to do is obviously pipe that to a file and then use Vim, because Vim is superior, guys. Okay, so we can just do vim.txt and look in here. And what's good to note is that, you know, this is a big file. It can be really big sometimes, but you're going to get to a point where you can see some human sentences, and this is what I like to call the application-ish layer of the code, because or at least it's like the data that is going to be used in that program. It's the logic that is used in that program. There's a lot of things that are underneath the surface that is irrelevant to what this application is going to do. But once we get into the human sentences, it's like, okay, this is more about what the application is doing. And you can see, I mean, it's a login form. So there's going to be some enter your username, enter your password. Great stuff here. There's also a flag, you know, a try hack me flag. This obviously, yes, is from Try Hack Me Challenge. Recommend it. Tryhackme.com. It's a great place to learn cybersecurity. I use it all the time. Not sponsored, just recommend using it. So with that being said, we can kind of see that this flag was supposed to be the password used in the login form. If you were to go into the login, if you were to go to login and if you passed in that flag, you would have recognized that, hey, this is the password used. And I would run it, but we are on a virtual machine, on a Kali virtual machine, so it sadly will not run if we try to run a Windows executable. So with that being said, there's one other thing I would like to show, and that is a decompiler. This is IDA. There's also Gehidra for y'all that like to use that. But what this is going to do is that we load in an executable file into here, and this program tries its best to decompile what the instructions are on a static analysis level. So just at point blank, you know, if we click the main and if we go to the main file, for all those C++ developers out there, you know that, hey, we start with int main. This is just the assembly instructions for the code and how it's working. And you could, you know, eventually piece together all these assembly instructions and find out the exact logic that's happening. However, that's not what we're worried about. What we're worried about are the static strings that are used. And you can kind of see here that the decompiler is smart enough to automatically detect that when a string is used, it's like, oh, let me just print out what's being used here. But if we double click here, we can actually go to the section of the executable of the file structure that contains all of our stored static strings, and bam, we would have our users, our usernames, and our passwords right here to use. Very cool. So what should we do instead? What we would do instead is not have the password in plain text in the file. If we needed a password to do something, it'd probably be a link to a server that needs some public private key verification in order to retrieve the password. Or maybe you just send a password and it gets validated on a backend server and you don't even have access to that password to begin with. There's a lot of ways to communicate without having stored information in the file itself, but just know that we want to have references to our secret information and not the actual secret information within our files. Just a quick and easy way of how to not get pwned. So thank you guys for watching. Peace.